Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover what is OCI Firewall, the solutions and services that are available today, what's planned next, some advantages customers have, and how easy it is to get started. I'd like to introduce Catlin and Brogdon as our main presenters. And now I'll hand it over to Catlin to begin today's session.
Hey, thank you, Stan. Good morning, good afternoon, good evening, everybody, wherever you are in this world. Together with Bogdan, we'll have a session on the OCI network firewall. So let's start it. So this is the agenda. We'll start with the introduction of the OCI network firewall. We'll follow with the use cases overview and some deployment steps. And we will finish with some architectural deep dives for two architectures. So why we are here? We are here to understand the challenges of securing the cloud infrastructure. We are here to learn about the top 4 most deployed scenarios by customers and to get a step-by-step network firewall provisioning and to get into 2 deep dives, walk through into a network firewall architectures. Okay, so according to a study, the enterprises are experiencing an increase in cyber attacks in their cloud infrastructure, and their IT professionals are afraid their security policies are not prepared for this. So the most common attacks include the exploit of data by using either phishing, malware, man-in-the-middle attacks to gain access to user credentials and to steal data. They will hold the data ransom and gain access to the critical data, encrypted it, and blackmail the enterprises to pay for the retrieval. They will steal the infrastructure by gaining access to the cloud infrastructure, for example, to compute and storage, and they will monetize it. Then they will not pay for them. So according to the studies, less than 50% of the enterprises are sufficiently prepared for the cyber attacks, and 92% of the IT professionals feel that the immaturity of their cloud security programs are creating a gap. Okay, what are the customer challenges? The main challenges of the enterprises deploying their workload to OCI is to protect their cloud infrastructure from cyber attacks. Enterprises are running their workloads in an environment where they can control all the entry points and manage the edge devices. Without this ability to control the network perimeter, some customers are hesitant to move to the cloud. So with threats constantly evolving, a traditional layer 4 firewall is no longer sufficient to stay protected from exploits and vulnerabilities, spyware, or malware. If you are deploying an OCI marketplace network security solutions, this is time consuming and it introduces complexity, and you need to apply patches, update the appliances, and maintain it. So the solutions to this problem is the deployment of the OCI network firewall. This solution is powered by one of the leaders in the industry, Palo Alto, and it is fully integrated into the cloud, so it's cloud native. And you can manage it with your CI/CD pipeline. So you can automate it with the OCI SDK. You can manage the firewall from the OCI. So logging is integrated into the cloud, so you do not need to use a third-party solution for this. Of course, the entire solution is automated and is scalable and active-active. Okay, the key feature of this service includes the stateful filtering, which you can allow or deny rules and based on the 5-tuple formation. Threat intelligence, which will prevent the network-based threats using the IDS-IPS solution from Palo Alto. It's URL filtering, where you can restrict access traffic to a specified FQDN. And of course, not to forget about the SSL inspection, which means that the SSL traffic is decrypted, inspected, and re-encrypted, all done natively. And observability. Logs and all the metrics are fully integrated into OCI. Okay, now we will introduce the defense in depth. And okay, defense in depth, why we need it? Because this strategy employs multiple layers of security to protect your data. And if one layer is compromised, you'll have the rest of the layers, not to feel totally insecure. So this means that starting from the edge, you will have layer by layer until you're getting to your application. OCI utilizes the defense in-depth strategy with employing both the web application firewall, WAF, and the network firewall. Okay. The web application firewall protects the applications from the common web-based attacks, and it filters the traffic at the application layer, inspects the HTTPS traffic for suspicious patterns and behaviors, and protects your workloads. The OCI network firewall complements this, and it provides a network layer security. It protects you against the network-based attacks. So it filters the traffic based the 5-tuple, and it has also a built-in IDS IPS. Okay, let's move to the use cases. So the first use case is the perimeter security, where you can protect your application and networks against vulnerabilities and against attackers until you have time to patch and to update. This means that you will enforce allow or deny rule based on the 5-tuples to filter the traffic. And in this example, the OCI network firewall is deployed in an allow list, deny list model. And you can see that the remote desktop protocol on the server, the request for the RDP uh, are permitted and the rest are denied. Okay, the second use case is the intrusion detection and prevention. So as I mentioned before, the network firewall is powered by the Unit 42 from Palo Alto. So we have the signatures based from latest threats. And this helps detect and block the known exploits and malware. So in this example, you can see a website that is hosted on the internet. And the OCI network firewall has been deployed with an intrusion prevention policy that looks for the signatures of malware and other vulnerabilities. In the client subnet, there is a client which unsuspectingly clicks on the link within that website, and the link contains a malware. So as the traffic returns to the firewall, it will get inspected, and the malware is detected, and the traffic will be prevented from reaching the client. And also a log is generated, and it contains the full details of the event. So a security administrator can inspect and can take further actions. Third use case is the selective access to the Oracle Services Network, to the OSN. So the Oracle Network Firewall can enforce the URL inspection, and it can grant access to a specified list of services in this case. So it can protect from outbound data exfiltration. So for example, from a VCN, from a client that can connect only to a specific service in the Oracle Services Network, not to all of them. So in this example, the firewall has been deployed with a selective service policy. So the HTTPS traffic is inspected, and the traffic that is destined to the streaming service URL endpoint, it is allowed, and all the other traffic, it is blocked. Okay, the fourth use case is the application segmentation and zero trust. This means that you will deploy a 3-tier architecture and you would like to implement a zero trust between the domain. So you will block the threats from moving laterally between the trust domains. And in this example, we are allowing the communication from the web to the app and from the app to the database, but we are not permitting the traffic from the web to the database. would like to also mention that, okay, everything is logged. So in here you have a sample of a log, and you'll have also metrics of the service. So these metrics will help you monitor the performance and the health of the service. You will have the alarms and notification. So you can configure them when they are reaching a threshold to issue an alarm trigger. And the logs will let you understand the threats and what kind of attackers coming in. And of course, we have the logging analytics, which will help you analyze the patterns, and you will be able to create dashboards, and you'll be able to drill down into the topologies and to do so much more. With that being said, I will hand it over to Bogdan for the deployment of the network firewall. Thank you.
We will analyze in a demo how the network firewall is being provisioned, what are the key points that we need to take into account when the network firewall is being deployed. And after that, we will discuss some very used use cases, and we will see how we will integrate the network firewall in our networking topologies to create a very secure network deployment, assuring that all the policies that are being applied are enforcing our how we will deploy the OCI network firewall. From the web console, we have the part called identity and security, right? And we need to find out under this category what is called the firewalls, right? We are seeing the firewalls at the bottom of the page. And here I will do a small pause here. The firewall tab has two sections: create the network firewall and create the network firewall policy. As you can see here, we are going first with the network firewall policy. Why is that? Because the network firewall policy will be requested in the network firewall creation. So first we will go with the network firewall creation, network firewall policy creation. It is very simple. We will just give it a name and hit the create network firewall policy button for this to be created up front. And after that, we will go with the next step, with the second step to create the network firewall. We will see that the process is very simple. The network firewall will be ready in just a couple of seconds. And here I will do a small pause, because in the left side of the screen, in the left side of the web UI, we have the core part of our network policy, network firewall policy, right? And we have the decryption rules, and the decryption rules are used for SSL and TLS decryption. After that, we can create the security rules. In order to create the security rules, we need to define our application lists, the services, the address list, decryption profiles, URL list, and after that, we will combine all these objects into our security rules. So all the engine, all the intelligence that network firewall will impose on the traffic is based on what we are going to create here after our policy is created and based on our security model, right? I will make this to run again. And remember, in the left side of the screen, we have all the actions that can be performed in a security policy. Now, the create network firewall is very simple. It will require a name. Sure, it can be a relevant name based on the design. Then, as you can see here, we have the network firewall policy, the one that we have created in the first phase. This is the reason it is important to have it up front. And then we will need to have the enforcement point. Now, the system will ask for the VCN and the subnet from that VCN where the network firewall will be created. This is called generically the enforcement point. Why? Because there the network firewall is being created and it is able to see what is happening in the VCN. There is just a single step to create the network firewall. And after this process is finished, we need to wait about 25 to 30 minutes in order for the network firewall to be created. Here in the center of the screen, we have the most important information that we will have for our network firewall deployment. After several minutes, right, 25 to 30, we can see here that the icon turns green. It is active. We have the IPv4 address of the network firewall, the policy that it is used, together with the VCN and the subnets where this network firewall was created. And here we should put a pause here. Let me do this one thing here because I want to show you something. Here we have our IPv4 address. This is important because in our examples, we will see that the OCI network firewall is acting as a bump in the wire, and this IP address associated with the network firewall will be used as next hops in our routing entries. Sure. The network firewall has some metrics: packet sent, packet received, and there is another important one, security rule hit count. So probably this will be very, very interesting to see when a certain security list was hit together with the decryption for SSL inspection traffic was used and how many times. Yeah. So in a nutshell, this is how to explore it a little bit deeper with some of the important details that we need to take into account when we are doing this kind of deployment, right? So let's go first with the network firewall deployment. As we saw on the movie, we have the identity and security tab, and under identity and security, we have the firewalls, right? The firewalls have two sections, network firewalls and the network firewall policies, right? Remember that it is better to have the network firewall policy created before the network firewall, because as we saw, the network firewall is actually requesting the policy, right? So we will go first, creating the OCI network firewall policy. And after the network firewall policy is created, in the left side of the screen, we have all the policy resources. Let's call it policy resources, because here we have all the intelligence. So defining our services, defining our URLs, defining our decryption profiles, we will be able to perform all the functions that the network firewall does provide. And suppose that we have a very simple case when you want to modify the content of the policy, or you want to remove something, or you want to add something. Well, in order for us to perform the change on a running policy, we need to clone the policy. So clone policy option, right? The clone policy will create a clone of the working policy, right? And you have the possibility to create, to remove entries, add entries, perform all the changes necessary. After that, the cloned policy or the new policy will be added to the OCI network firewall, replacing the one that it is running. The connections will still run and will suffer a connection reset only if you have modified the mapped secret information. The mapped secret is used mainly for SSL decryption. So if we want to have traffic, SSL traffic decrypted and analyzed, we need to create the mapped secret based on a very simple procedure. So if we change the mapped secret in our vault or authentication profiles, then the connections using the mapped secret which was modified will be reset. Otherwise, all the connections will just flow without any interruption. So this is a very important point with the clone policy and how we can update a running policy on the OCI network file. We have our policy in place. Everything is set it up. We are ready to go and create the OCI network file. Creating the OCI network firewall will request some very simple information like a name, the policy that we want to use, and the enforcement point, right? And here you have also the possibility to assign a manual IP address from the subnet in order to have a predefined IP address where we will use it in the route entries. We will see in our use cases how we will use the IP address associated with the network firewall. Again, it will take about 20, 25, 30 minutes at maximum to complete. And after it is completed, we have our network firewall in the active state, running and ready to be used for our security purpose. Right. Now we have the IPv4 address. It is supporting also IPv6 address, the network firewall policy, and VCN and the subnet where it is actually deployed. Everything is set it up now. You have your network firewall in place, you have your policy in place. Now the network firewall is just waiting to be used as a bump in the wire. Again, the OCI network firewall does not change anything at the traffic level. It is just sitting there waiting for the traffic to be received and analyzed, right? This concludes our deployment part. And now we will go to see how we will integrate the OCI network firewall in our architectures. For the sake of discussion, I prepared two use cases. One of the, let's say one of the most use cases, and this is the OCI network firewall and the internet gateway. So the combination between the internet gateway and the OCI network firewall will use this simple networking diagram where we have the internet gateway, then we will have the OCI network firewall deployed in a subnet within our VCN, and another subnet holding a virtual machine, a test virtual machine with public and private IP address, right? We want to expose this virtual machine to the internet. So the virtual machine must have a public IP address, right? And this public IP address is 192.18. The other IP address, which is the private one, is 192.168, right? The purpose is all the traffic that it is originated from the internet to our test VM and from the test VM back to the internet to flow over the OCI network firewall. And the request is very simple. We have two hosts within internet, one starting with 150, another one starting with 192.9. So the request is to allow the ICMP and SSH from 150 and deny the ICMP and SSH from 192.9. So only 150 has the right to access virtual machine 1 over the OCI network firewall. Actually, the OCI network firewall will do all the three. Let's see it in action. First thing first, we need to have the network firewall as a bump in the wire. That being said, all the traffic that flows from the internet to the VM and from the internet back to internet needs to flow over the network firewall. So we need to instruct OCI to route the traffic over the OCI network firewall. And remember the IP address that was assigned to the OCI network firewall, because we will use it now in routing entries at the subnet where the VM is located, at the subnet where the network firewall is located to send the traffic to the internet, and on the internet gateway. Let's look at the virtual machine. So the virtual machine, in order to send the traffic to the internet over the OCI network firewall, will have a default route. The destination will be the quad 0, and the next stop will be our network firewall. So our traffic will flow from the subnet where the VM is located to the network firewall. Once the traffic hits the network firewall and it is inspected, then the network firewall needs to send the traffic out. So the route that it is included in the route table associated with the network firewall subnet will have a default route pointing to the internet gateway as next hop. So my traffic is reaching here, the internet gateway, and from internet gateway, it will go to the internet, right? The reverse traffic, or the traffic that it is sent from the internet to our VMs, will hit the internet gateway, and here the internet gateway will have its own route table associated, and this route table will contain a specific route for the subnet where our VM1 is located, and this is 192.168.0.0/28, via the network firewall as a next hop. So my internet gateway will send all the traffic for my VM1 subnet over the network firewall as next hop here. Right. So the routing is very simple, it's very intuitive. And now, taking into account that the network firewall from the routing perspective was configured as a bump in the wire, let's see its actual configuration on the security side. So how we will permit the ICMP and SSH from one node and deny from the other node. Sure, we need to define first, if you remember, the left side of the security policy where we can have the IP address lists, right? And here we have one IP address list that it is called permit, containing the 150 node, the IP address deny, which is 192.9, and our VCN hosts, the VM which sits inside the VCN, which is 192.168.0.10/32. Right. Now we have defined our IP address lists. Let's see how the security rules. We know that in order to define a security rule within OCI network firewall, we need to have our IP addresses defined, our URLs defined, our services defined, right? In order to have the match as specific as possible. So let's create now the security rules based on the IP address list that we have defined in the right side of the screen. First thing, we will define our first security rules as ICMP permit, where we will specify the source being the IP address permit and the destination being the VCN hosts. From here, we want to permit the traffic from 150 to our VCN host, and the application is ICMP, right? And the action is allow traffic. The other one, SSH permit, is from the same source to the same destination with application SSH. Again, with a low statement, a low traffic statement. For the drop traffic or deny rule, that will be from 192.9 back to VCN, will be from IP address list deny, which contains 192.9, to our IP address list VCN hosts, which is our virtual machine. And for any protocol, I don't want any traffic to flow from this node back to my VM, I will drop this traffic. Right. After generating some traffic, we can analyze the logs. Network firewall is having a very powerful system log where we can find a lot of useful information. Let's see it in action. We have generated some traffic from 150 and from 192, and let's see how this is looking at. This is the allow log. So from 150, we can see that we have the action allow, we have the destination IP address, we have the source IP address from where the traffic is coming, together with the rule that was used to allow this traffic. So a lot of useful information. This is what we are searching for in a troubleshooting session. All this information are very useful when we want to troubleshoot connections or even something that it is not filtered as expected. And the same is true for the SSH, right? Here we have ICMP, the protocol, because we want to permit the ICMP. Here, the destination port number is 22, specifying that this is an allowed SSH session from the same source to the same destination, having another rule to permit this traffic, which is a SSH permit. Right. Let's see how the logs looks like when the traffic is generated from the non-allowed source, which is 192.9. Right. We have here the action drop on both scenarios, ICMP and SSH. We have the same destination because our target is the same virtual machine, but the source is the same together with our protocol ICMP here and destination port 22 here. So this proves that our security rule implemented on the network firewall did the performed task, and now our traffic is managed in the way that our security model is requesting. Right? So this is a very good point to start and verify if the network firewall is performing based on the configuration applied. Now, a second case is to combine the OCI network firewall with the NAT gateway. We will change a little bit how the traffic flows, but we will maintain the same structure from the routing perspective. Let's see it in action. What we have here, we have replaced the internet gateway with the NAT gateway. We stripped out the public IP address from our virtual machine. We maintain the network firewall in the exactly same position with the exactly same IP address. And we have our 150.136 server on the internet hosting 3 URLs, 3 FQDNs, production1test.com, production2test.com, and production3test.com. The request is very simple. Our virtual machine from the private subnet can access via the NAT gateway only production 1 and production 2, but not production 3, right? Over TCP port 443, right? So it is a very simple case where the network firewall should be configured for URL filtering, right? In the exactly same way, we need to make the network firewall to receive this traffic. And we have also already discussed this routing part. The routing rules that we will have here at the VM will stay the same. A default route pointing to the network firewall. Then the network firewall will point its default route to the NAT gateway, right? And the NAT gateway for the returning traffic will point to the network firewall for the virtual machine 1 subnet. Right? So now, taking into account the routing configuration, we are sure that our traffic is flowing over the network firewall, and we need to analyze the configuration that needs to be done on the network firewall for the URL feature security model that we want to have in place. Let's see. Here, we need to have our application lists defined. We want to have HTTPS, port range 443, and the URL lists. The URL list will contain what I call blacklisted sites and whitelisted sites. Blacklisted sites will be production3.test.com, and the whitelisted will be the other two, production1 and production2. So this will be our URL lists created together with the application, and now the security rule that will use what we have defined above, right? So we will create an HTTPS permit rule where the source will be my virtual machine to the destination 150, which is the host from the internet, using the application HTTPS and the URLs whitelisted sites. Remember, production 1 and production 2 with green here and allow traffic as an action. And the HTTPS deny will be from the same source to the same destination, but the URL will be the blacklisted site production3.test.com with an action of drop. So we have a drop traffic here. We have generated some traffic from our VM. Remember that the NAT gateway is performing the source NAT of the traffic. It will replace the source IP address of the virtual machine with its own public IP address, right? And will send the traffic to our internet destination, which is 150. And let's see how the logs are looking in this case. Here we have the allow log, and here we have the drop one. Right. So here we have the destination port 443, the destination IP address, the source IP address, and the rule that was used to permit the traffic to production 1 and production 3, which is HTTPS permit. Right. And the drop traffic was used the HTTPS deny rule that we have created here, this one, right? From the same source to the same destination over port 443. So immediately we can have the conclusion that the network firewall is performing as expected and our traffic is filtered and allowed based on the policies that we have created. And now just a small thing, suppose that you already have this in place, this policy or these policies are in place, you want to add something more, you need to apply the clone policy. You need to clone this policy, update it, and then reapply it to the OCI network file, right? And everything will work just fine, and your traffic will not be interrupted if nothing was changed on the map secret part, which is used for SSL decryption. Now, in a nutshell, the OCI network firewall can be integrated in most of the advanced networking scenarios. It can be a standalone VCN with public-facing application, or it can be a very complex networking scenario where we have a central point of inspection, where we have the OCI network firewall or multiple OCI network firewalls to inspect from the IDS IPS perspective, SSL decryption and inspection, and from the traffic inspection. It can be north-south, it can be east-west traffic. These all can be combined. This all can be done with the network firewall in front, because again, the network firewall is only acting as a bump in the wire, and from the routing part, we can control how the traffic is actually flowing within OCI. Right. So yeah, this is a very powerful networking and security feature that OCI can offer to our customers. Thank you so much. I will some very good resources that you can follow in order to see, let's say, more use cases regarding the regarding OCI network firewall, and these are some of the, let's say, most advanced use cases and explanations that we have for the OCI network firewall, and see how we can integrate it in our customers' networking topologies.
Do we have?
Let me read out the next question before you answer. It says,
Yeah.
will there be any downtime when we apply new policy to NFW by closing existing policy?
Yeah, this is a very good question. The clone policy itself will not produce any downtime. So the traffic will run without any issues. After you are cloning the policy, after you are finishing with updating the policy, you will go to the network firewall and specify that you want to use your new policy that was updated. So now it comes in the discussion, that map secret part. If you didn't change anything on the map secret, on the decryption profiles, on the things that are stored in Vault for SSL decryption, the connections will not be interrupted. So everything will flow without any problems. For example, you add another pair of IP addresses that you want to monitor, right? Or you will do some other things which are not implying any map secret. No connections will be reset. Only and only if you are changing that map secret. Once you are enabling, it will use that for the SSL decryption, and the ongoing sessions needs to be restarted. Main difference between Palo Alto and OCI firewall. Well, here we need to discuss, because Palo Alto has some other functions which are not available on the OCI network firewall. And one of the reasons for that to not be there is because we implemented the most requested features. Sure, we have working in place to integrate some other functions, but there are some differences between a legacy Palo Alto and the OCI network firewall. And I will tell you one thing. regarding the OCI network firewall. OCI network firewall is active-active, so you don't need to worry about redundancy. But if you are going with Palo Alto, we need to maintain the cluster, or if we want to go in active passive, or we need to have at least 2 instances of Palo Alto sitting behind the network load balancer in order to achieve a sort of redundancy. But there are some differences. This is what I wanted to point. There are some differences between the Palo Alto and the OCI network firewall in terms of features. Does the NF allow you to control the address multicast or IGMP? Okay. By default, OCI does not support any multicast or IGMP. So neither network firewall doesn't have this type of capabilities, right? Overall, the cloud providers does not permit the multicast and IGMP to flow, but we have a solution. If you are interested in multicast and IGMP, we have a solution from one vendor, and yeah, I was leading that project, where OCI can support multicast. And the partner is Switch.io. It is not related to network firewall, but the most interesting thing is that the traffic, or if you want, the multicast traffic that it is creating with that overlay network can be inspected by the network firewall, but the network firewall doesn't have any multicast capabilities at all.
There was another question. When you apply a new policy to NFW, will there be any downtime?
Yeah, I just responded that. So if you are not, but I can repeat. So if, for example, you are modifying the CON policy and you are not changing anything on the map secret that it is created for the SSL decryption in Vault and in authentication profiles, then you will not have any connection reset. So everything will work without any issues. Only and only if you are doing the map secret change in the vault associated with the network firewall for SSL decryption, you will have so the connection will be reset. This is the reason that we are specifying that each and every time when this kind of actions, when the action is performed on the map secret, that to be done in a maintenance window. Can we have more than 2 interfaces on the OCI firewall? Yeah, this is a very good question, and it is something that we are receiving very often. No, OCI network firewall is providing just only one IP address, and that is assigned on its interface. But we do not have the way to create a sort of incoming and outgoing interface on the network firewall. Why is that? Because that single interface, network firewall can process, as of now, you will start with a shape of 4 Gbps of traffic, and that can be increased to 12 Gbps traffic for the larger shape. We are preparing to have 25 Gbps network firewall shape in the future. So this is one of the reasons that network firewall doesn't support multiple interfaces. It is having just only one. Thank you so much.
This session and would like us to conduct personalized training for your organization, do email us at our personal training email and we'll reach out to you. If you want us to conduct just a hands-on lab, we have a newly designed Quick Shot Live Labs program for a more expedited hands-on learning experience. For specific cloud topics, under the Cloud Innovate program, we co-developed a solution based on your own use case. Please remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Our next session will be on July 21st. In this session, you'll be introduced to the fundamentals on building resiliency with Oracle Cloud Network Monitoring and how to start your account off correctly with best practices. With that, thanks for joining today's session and have a wonderful day.
There is one more question in the Q&A, Bogdan. It says, if you want to allow egress traffic for particular URL like tenable.io for scan, and it has dynamic IPs, how can we implement with NFW or WAF?
So for this, it will be the URL that will be inspected. So it is not the URL filtering. It's independent by its IP address. So when you will have that, the network firewall will inspect the HTTP header, and we will see, and it will see what is actually requested. And sure, it can be also done with the WAF, but it will not. When you are going with URL filtering, the OCI network firewall needs to know what is included in the HTTP header and what is requested. And based on that particular part, will enforce the security.
Thank you, Bogdan.
Sure.
Thank you, everyone, for joining. Hope you all had a great learning experience today. Have a good day, everyone.